Okay, we're going to forge forward, and this example is showing you where we have the Laplace of kind of like two functions added together, where we started in our original discussions, where we have this thing here where you can do a transform on two things to get summated together, and because of the property of linearity, you could separate them and keep rolling. And this is going to be the case here. See, so you have um, the property of linearity. You take the Laplace of this summation or difference, whichever, and because you have the constant, you can pull them in front. We discussed that, and then you can just operate on the t, and then that's the Laplace of t. Minus 5, take the constant forward or ahead of it, and then that's the Laplace of sine 2t. Okay, and now without going too crazy here, I'm going to show you that we actually did this problem, the Laplace of t, in a prior video. And when I did do that, I got a value of, uh, let's see, notes 5. I don't know, notes 5. Okay, we're missing notes 5. Okay, so I got a value of 1 over s. Okay, so it's 3 times 1 over s in a prior video. Minus 5, and we just did this problem, sine of 2t, which is 2 sine squared plus 4. Okay, so that one we just computed, and so there you have it. You're all set with uh, there's 5. Okay, so here we did the Laplace of t is 1 over s squared. Okay, so now you've got everything in the s domain for this combination of functions here, but now you got to kind of put them together. So this is algebra, and you're just going to get a common denominator and maybe do some other things here and factor things and cross things out, whatever you have. But here's your final answer right there. Okay? And for s greater than 0, uh, because in this case, well, you'd have to have s can be anything here, and it's still going to multiply out and be positive. But here's the constricted point is because of the s in the denominator, you have to have s must be greater than 0. So it's defined. Okay, now moving on, I'm going to try to knock out another one here. We're going to evaluate Laplace of t e to the minus 2t. Okay, and then Laplace t squared e to the minus 2t. All right, so the first one, a, I put it into our definition of the Laplace, and I put the function here. Here's your f of t, okay, inside, and so uh, how does this work? Well, we have to do integration by parts, okay, and so when I do integration by, well, first we're going to combine these. We got the e to the minus st, e to the minus 2s. So I could just put a minus in front, and then it's really s plus 2. See, so it's minus s minus 2 with the t outside. Okay, both t outside. So I keep the t outside, but it's s plus 2 with a minus in front. Okay, now we're doing integration by parts. We want to put the t for the u so we could derivative it out to nothing, basically, if we have to. And then the v prime is going to be the e to the minus st, s plus 2t. Okay, we have to put the compensation factor in here, and there it is. So when you take the integral, you get minus e to the minus s plus 2 t over at s plus 2. Okay, so now you're going over here and putting this into the integration by parts formula. Okay, so you have the v and u, okay, right here. But as you know, as you go to infinity with this guy over here, okay, as t goes to infinity, 0 to t, this is all going to drop out and go to 0, as we've seen so many times already. Okay, so now you have the integral of 0 to infinity of the u prime and the v. Uh, right. So here you go. You have all this rewritten here, and your u prime here, and then uh, that gets pulled out as a constant. This s plus 2 minus s plus 2, it becomes plus 1 over s plus 2. Okay, and then you have multiplied by the integration of this, which is here. Okay, the integral of what's left here is this with the compensation factor, and that's with the limit of 0 to infinity. So you take the upper, and that goes to 0 again, but the lower doesn't go to 0, and you get 1 over s plus 2 squared, where s must be greater than negative 2 here, because if you have a negative 2, then this will go to 0, okay, and be negative. All right, so s must be greater than negative 2. Okay, so there you go. You're done with that one. One more to go, and this is b. Uh, you have t squared, e to the minus 2t, and we do integration by parts in this, and I'm going to let you look at it a little bit here so you can get it. So this becomes 0 to infinity, okay, plus these factors are brought out in front, and you're getting 0 to infinity, and this is what remains. And basically, uh, when we bring this out front and we have the Laplace of this. Well, we just did this, the Laplace of this, and so we end up with 1 over s plus 2 squared. Okay, so we just did this one in part A. So now you have both of these put together, and this is what you end up with. Okay, so now we've completed the preliminary work of Laplace, and we're going to see how we could address all this in a nice table and save ourselves a whole bunch of time and going forward. And you're a professional at the forward direction of Laplace, and you're getting closer and closer to being able to take care of differential equations using this. Thank you.